Hey guys, happy Wednesday. This is Miss V. We're going to continue today with topic 8.8a, part 2, which we are focused on writing equations with variables on both sides to represent mathematical problems. All right, so I wanted to start off by going over the exit ticket from yesterday, just so that you can check your understanding to see if you're getting it and to see if maybe you need a little extra help to attend the live sessions. So, question number 1, it says the sum of 4 times a number and 3 is the same as 5 minus twice a number. So first things first, guys, remember we are writing equations. So there is a left side and a right side to an equation, and we have to describe or to translate these words into mathematical terms to describe the scenario. So let's get started. All right, so on question number 1, the first thing is that you want to find where the two expressions are separated. And to easily do that, you can see where it says the same as. That means your equal sign is going to be there, which separates the left side of the equal sign, which is here, from the right side of the equal sign, which is here. All right, so now that we know which side is the left side and which side is the right side, now we can get started on writing our equation. So the sum of 4 times a number and 3. So right off the bat, one of the vocabulary terms that I notice is sum, and I know that that means I'm going to be adding two things together. All right, I just need to figure out those two things. The next part, if I continue reading, it says 4 times a number. Now, this is not a specific number. It doesn't tell me what exact number this is. It just says some number. So that's how I know that that's my variable. 4 times the number, meaning I'm actually going to multiply 4 times the variable. So we can just write this as 4 as the coefficient and x as my variable. And then it says and 3. So that's the second thing that I'm adding. Now let's jump to the right side. It says 5 minus twice a number. So it gives us, again, now we're talking about the key operation here is minus. Okay, so in order to subtract something, I need obviously two things as well. So the first number it gives me is 5 minus twice a number. So again, here's that variable, a number. Again, we don't know, but this says twice. Now again, twice stands for 2. Okay, you can kind of see it right there, twice. So this is 2x. So for number 1, you should have had 4x plus 3 is the same as 5 minus 2x. So hopefully you got that right. Give yourself a pat on the back if you did. And let's continue on to question number 2. This is a more lengthy word problem where vocabulary is key to understanding and determining what operations are being used. All right, so Ronald rents a car from Cheap Rent-A-Car for $25 plus 5 cents per mile. Dixon rents a car from Great Cars for $40 plus 3 cents per mile. For what number of miles is the total cost charged by the companies the same? All right, so again, we want to find the total cost charged by the companies that's the same. So that's telling me that, again, I'm going to set these two companies equal to one another, meaning one company is going to be on the left and one company is going to be on the right. All right, so I'm going to first start with Ronald. Ronald. Okay, and he's going with Cheap Rent-A-Car. Now, it says that he can rent a car for $25 plus 5 cents per gallon. So this first part makes it easy. $25 plus. So I know I'm going to start with 25 and I'm going to be adding something. Now the second part, it says 5 cents per mile. Now it doesn't give us the exact number of miles, it just says per mile. So again, when it's our unknown, we're going to represent it with a variable, x, and 5 cents is our coefficient. So 5 cents x. Okay, moving on to the right side. Here now we're talking about Dixon. So here I'm going to erase this really quick to get a better view. All right, So moving on to Dixon, it says that he rents a car from Great Cars for $40 plus 3 cents per mile. All right. So again, we are kind of the same situation. We know this plus means we're going to be adding two things together. Okay. We know that we are automatically going to get charged this $40. All right. So 40 plus 3 cents per mile. Again, this per mile is our variable because it's an unknown number, and our coefficient is 3 cents. Okay, so the equation you should have had for number 2 is 25 plus 5 cents x equals 40 plus 3/100 x. All right, so again, give yourself a pat on the back if you got that correct. That is awesome job. If not, no worries. That's what today is for. We are going to continue with more practice problems. Okay, so just a quick recap. We do need to know the different parts of an equation here. Again, if we focus on our equal sign, it separates it into two expressions. We have the left side, and then we have the right side, and again, they're set equal to one another with this nice equal sign. All right, so again, we have this is one term, this is two terms held together by an operation. Same thing on the right, one term, two term held together by an operation. Within this term for x, we have the coefficient, which is the 4, and the variable, which is the x. Same thing on the right. Here we have our second term is 2x, so we have 2 as the coefficient, y as the variable, and they each have a constant. Again, a constant is a number that stands alone with no variable. On the left side, it's 3, and on the right side, it's 6. All right, so make sure that you're getting familiar with that vocabulary. If you need more help, there are flashcards here on the home screen. Make sure you click that through Quizlet, and you can quiz yourself or you can have someone quiz you. But again, that is there for extra help. All right, so let's get down to some more practice problems to help you better understand this topic. And again, we're going to be using this kind of table situation where we are taking one event and setting it equal to another event, or taking the left side and making it equal to the right side. Another thing, vocabulary is super duper important. Again, we need to be able to distinguish what vocabulary words within a word problem are telling us what operations to be used. All right, so take a minute if you want to pause, go ahead and familiarize yourself with all of these words that could equal this. And again, you can always come back to this video to help. Okay, all right, finally, example number 1. Graham is hiking at an altitude of 14,040 feet and is descending 50 feet each minute. Max is hiking at an altitude of 12,500 feet and is ascending 20 feet each minute. How many minutes will it take Graham and Max to meet at the same altitude? All right, so again, key word, same altitude, meaning we are going to set Graham and Max equal to one another. So my left side, I'm going to put a big G over here for Graham. On the right side, I'm going to put an M over here for Max. And we already have our equal sign here. Okay, so let's focus on Graham first. It says that he is hiking at an altitude of 14,040 feet. So that's the given. We know that for sure number. So I'm going to start my expression with that number. As I continue reading, it says, and he is descending. Okay, guys, vocabulary, key thing here. We have to distinguish whether descending is addition or subtracting. So descending sounds like decreasing. We're going down. We're getting smaller. So descending is subtraction. And we are subtracting by how much? It says 50 feet each minute. Okay, now we don't know how many minutes. We just know that he's descending 50 feet each minute. So minutes is our variable, 50 is our coefficient. So we have 50 x for gram. Okay, moving to the right side, max. I'm going to clear a little bit of this. All right, so let's look at max. It says Max is hiking at an altitude of 12,500 feet and is ascending, okay, at 20 feet each minute. Okay, so we know that he's at 12,500 feet. So we can go ahead and write that part of our expression, 12,500. And then it says, and is ascending. So we need to figure out what this word ascending means, or we need to figure out what operation it would be for, either addition or subtraction. And again, from last unit number 1, we should know ascending means going from least to greatest. So we're starting small and we're getting bigger and bigger. So that's going to lead me to addition. All right. And it says 20 feet each minute. And again, just like gram, we don't know how many minutes. So that's our variable, but we do know it's at 20 feet each minute. So 20 is our coefficient and x is our variable. So our equation, when we set these equal to one another, should be, and I'm going to write this down here because these two lines aren't going to be big enough. 14,040 feet plus, minus 50x is the same as 12,500 feet plus 20x. All right, so on this next example, I want you to go ahead and pause the video and give it a try and come back and see if you got the correct answer. So go ahead and click pause and come back in just a few minutes. Okay, so hopefully you're back and hopefully you have an equation. Let's go ahead and read number 2. Nick and Adam work out together. Nick weighs 160 pounds and is gaining about 3 pounds per week. Adam weighs 195 pounds and is losing about 2 pounds each week. Write an equation that can be used to find the number of weeks that it will take them to weigh the same amount. So we're trying to figure out how many weeks is it going to take these two gentlemen to weigh the same, or when are they going to be equivalent in weight. All right, so we got it set equal to one another, and it gives us two different people. So we have Nick on the left and we have his friend Adam on the right. So let's focus on Nick first. It says Nick weighs 160 pounds. Okay, so we know that. All right, and then it says he's gaining. If you had to choose an operation for gaining, hopefully you chose addition. So I know that he's going to start off with at 160 pounds. If he's gaining weight, that means he's adding. And it says 3 pounds per week. All right, so again, we don't know the number of weeks. Okay, we don't know the number of weeks. That's our variable. That's x. But we do know it's at 3 pounds per week. So our coefficient is 3. Our variable is x for Nick. Okay, Adam, it says that he weighs 195 pounds. Okay, 195 pounds. All right. And then it says he's losing. All right. So if, again, you're wanting to choose an operation for this term losing, hopefully you chose subtraction. And it says at about 2 pounds each week. All right. So this each week, again, it doesn't tell us how many weeks. It just says each week. So that's our variable. And our coefficient is going to be this 2 pounds. So 2x. Okay, so when we put that together, when we set them equal, we should have 160 plus 3x is the same as 195 minus 2x. All right, hopefully you got that. If you didn't get it, maybe you got the left side right and maybe made a mistake on the right side, but that's okay as long as we are still practicing and at least getting some of them right. And again, if you're not getting them right, guys, please join me during the office hours, which again are at 9:30 and 2, okay, to maybe let me answer any questions that you might have and clear up any misconceptions or misunderstandings that you are not getting. All right, so moving on to example number 3. JC has a VIP membership to a movie theater, so she pays $27 a year and $600 for each movie she sees. Claire doesn't have a membership, so she pays $8.25 each movie she sees. How many movies could they have to see in a year in order to pay the same amount? All right, guys, so again, we're looking at how many movies it's going to take them to pay the same amount. Okay, so we're going to set them equal to one another. We have JC on the left and we have Claire on the right. We're going to focus on the left side first. So JC says that she's paying $27 a year. So we know that. We know that she's paying this much money. And then it says she pays $6 for each movie she sees. So it doesn't tell us how many movies she's watched. Okay, so that's our variable. So each movie, that's X, is $6, which is our coefficient. And again, she's already paid it, and if she's going to watch these movies, it's adding up every single time. So we're going to use addition, and 6X. 6 is representing that $6. I just dropped the zeros because they were after the 6. Okay, Claire. It says Claire doesn't have a membership, so she pays $8.25 for each movie she sees. All right, so unlike JC, we're not given a number to start, but it does tell us that she pays $8.25 for each movie she sees. So it doesn't tell us how many movies she sees. Okay, so that's our variable X, but each time she's paying this $8.25. So that's our coefficient. So 8.25, and we have X is our variable. So when we set these equal to one another, our equation should be 27 plus 6X is equal to $8.25 times X. All right. Example number 4. Okay, guys, so I put this example in here. If you notice, it's been different from the other examples because I wanted to give you an insight as to what your assignment for today is going to be because it is graded, and I wanted you to see what it looks like so that way you can make the best grade possible. So in the assignment today, you're going to be given 5 task cards that look like this. Each one will have a different scenario. The same type of problems that we've been doing today, except for they give you answer choices. So we're going to work through this one together. I will end with example number 5, so you can leave your answer in the discussion, and that'll be it. So let's get started. Example number 4, it says bucket P and bucket Q are both leaking water. Keyword right there, guys, leaking. This is going to come in handy, okay? Be thinking about what operation might go with leaking. Bucket P contains 750 milliliters of water and is leaking 8 milliliters per minute. Bucket Q contains 800 milliliters of water and is leaking 12 milliliters per minute. Which of the following equations can be used to find M, the number of minutes it will take for the 2 buckets to have the same amount of water? All right, so we want to find where they're the same. So we're going to set them equal to one another. Okay, we have bucket P and bucket Q. All right. Now, leaking. Hopefully, let's go back to that word leaking, and hopefully you thought about subtraction. Again, you're losing water. All right. So we know that both of these buckets are losing water. So I know both of my expressions are going to have subtraction in them. Okay, because they're both leaking water. Now, bucket P says that it's starting with 750 milliliters. So I'm going to put that here in bucket P. And again, we talked about subtraction because of leaking. And then it's leaking at a rate of 8 milliliters per minute. Okay, guys, we don't know the number of minutes. Okay, that's our variable, and our coefficient is 8 milliliters. So this is going to be 8x. Bucket Q, let me erase this so we can just see a little better. Bucket Q says it contains 800 milliliters of water. So it's starting with 800. But then it says it's leaking at a 12 milliliters per minute. So again, we don't know the number of minutes. That's our variable. But the coefficient is 12 milliliters. So 12x. So when we set these two together, we should have 750 minus 8x is equivalent to 800 minus 12x. Now, guys, if you notice, I suggest that you work it out yourself first and come up with your own equation, because if you notice in your answer choices, they're all using the exact same numbers. They're just moved around in different places. So I would suggest write your own equation first and then match it with one of the answer choices here, all right? And again, since we have our own, we can clearly see that our answer should also be C, because that's the only one that actually starts with 750, okay? So again, hopefully you're getting the hang of this now, and I will leave you with example number 5, and make sure you put your answer in the discussion. Okay, one more thing, sorry guys, before you start on this example number 5, I wanted to show you what the assignment's gonna look like. You're gonna look for this Google form here, okay, and you're gonna fill in the information required, such as class period, student name, and student ID. Make sure you get that filled in first and correctly so that you are given the correct grade. And then you can continue on with the task cards. Like I said, there's only 5. And the task cards look exactly like this example that we're going to end on today. All right, so solve this example number 5. You can leave your answer in the discussion. You don't have to type the equation out, guys. You can just leave A, B, or C, whichever one you get as the answer. And that is it. I hope this helps you, and hopefully I see you at the lives today at 9:30 and 2, and have a great day.